NFPA 99. The Healthcare Facilities Code, Chapter 8 addresses electrical systems. Section 8.2.1.2 pertains to grounding, specifically 8.2.1.2.1 addresses isolated grounded electrical systems. This section states that the power supply distribution system in critical care areas shall be a separately derived system. Section 8.2.1.2.3 addresses non-isolated grounded electrical systems. This section states that the power supply distribution system in critical care areas shall be a ground reference system. There is no provision in NFPA 99 that allows for non-isolated ground receptacles in operating rooms for emergency purposes. This is a crucial point to understand for maintaining electrical safety in healthcare environments. Isolated power systems are used in critical care areas, such as operating rooms, to minimize the risk of electrical shock. These systems are designed to prevent a single point of failure from causing a dangerous voltage to ground. A separately derived system means that the power source is isolated from the main electrical service, typically through a transformer. This isolation creates a floating ground, which limits the current that can flow in the event of a ground fault. In contrast, a ground reference system is directly connected to the building's grounding system. This provides a low impedance path for fault current to flow, which can trip a circuit breaker or ground fault circuit interrupter (GFCI) to de-energize the circuit. The misconception that non-isolated ground receptacles are permitted for emergency purposes likely stems from a misunderstanding of the underlying safety principles. The primary goal in critical care areas is to maintain a safe electrical environment for patients and staff. Introducing non-isolated receptacles would compromise the integrity of the isolated power system and increase the risk of electrical hazards. When designing or maintaining electrical systems in healthcare facilities, it is essential to adhere strictly to the requirements of NFPA 99 and other applicable codes. Failure to do so can have serious consequences, including electrical shock, equipment malfunction, and even fire. To ensure compliance, it is recommended to consult with qualified electrical engineers and healthcare facility professionals who have expertise in these specialized systems. Regular inspections and testing of electrical systems are also crucial for identifying and addressing potential hazards before they can cause harm. The isolated power system typically consists of an isolation transformer, a line isolation monitor, and appropriately grounded receptacles. The isolation transformer provides the electrical isolation, while the line isolation monitor continuously monitors the impedance to ground. If the impedance falls below a certain threshold indicating a potential ground fault, the line isolation monitor will alarm, alerting staff to the problem. This allows for corrective action to be taken before a dangerous condition develops. The grounding of receptacles in an isolated power system is different from that in a standard grounded system. In an isolated system, the ground wire is connected to a separate grounding electrode, which is isolated from the building's main grounding system. This further reduces the risk of ground loops and unwanted current flow. The use of isolated power systems in critical care areas is just one example of the many safety measures that are implemented in healthcare facilities to protect patients and staff. Other important measures include regular training of personnel, proper maintenance of equipment, and the use of appropriate personal protective equipment. Electrical safety is a shared responsibility, and everyone who works in a healthcare facility should be aware of the potential hazards and the steps they can take to prevent accidents. NFPA 99 provides detailed guidance on all aspects of electrical safety in healthcare facilities, including the design, installation, and maintenance of electrical systems. It is essential for all healthcare professionals and electrical contractors to be familiar with the requirements of this code. In summary, NFPA 99 does not allow for non-isolated ground receptacles in operating rooms for emergency purposes. The use of isolated power systems is required in critical care areas to minimize the risk of electrical shock. Adherence to these requirements is essential for maintaining a safe electrical environment in healthcare facilities. Understanding the nuances of isolated and non-isolated grounding systems is crucial for anyone involved in the design, installation, or maintenance of electrical systems in healthcare environments. Incorrect application of grounding techniques can compromise the safety of patients and staff, leading to potential electrical hazards. To further clarify the distinction between isolated and non-isolated grounding systems, let's delve into the technical aspects of each. Firstly, an isolated grounding system, as the name suggests, isolates the equipment grounding conductor from the normal building ground. This is achieved by running a separate, insulated grounding conductor from the receptacle or equipment back to the separately derived source, typically an isolation transformer. This isolated ground conductor is not connected to the building's steel or other grounded metal components along its path. The purpose of this isolation is to minimize the flow of unwanted noise currents in the grounding system. Noise currents can interfere with sensitive electronic equipment, leading to malfunctions or inaccurate readings. By isolating the ground conductor, these noise currents are prevented from circulating through the building's grounding network. Secondly, a non-isolated grounding system, on the other hand, connects the equipment grounding conductor to the building's normal grounding system. This means that the grounding conductor is bonded to the building's steel, metal conduit, and other grounded metal components. This provides a low impedance path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and de-energize the circuit in the event of a ground fault. Non-isolated grounding systems are the most common type of grounding system used in general electrical installations. They are simple to install and provide effective protection against electrical shock. However, they are more susceptible to noise currents than isolated grounding systems. In healthcare facilities, the choice between isolated and non-isolated grounding systems depends on the specific application. In critical care areas, such as operating rooms and intensive care units, isolated power systems are required to minimize the risk of electrical shock. In other areas of the facility, non-isolated grounding systems may be acceptable. It is important to consult with qualified electrical engineers and healthcare facility professionals to determine the appropriate grounding system for each application. The line isolation monitor, LIN, is a critical component of an isolated power system. It continuously monitors the impedance between the isolated power system and ground. If the impedance falls below a certain threshold, the LIN will alarm, indicating a potential ground fault. The alarm does not necessarily mean that there is an immediate danger, but it does indicate that further investigation is needed. The LIN alarm allows healthcare staff to take corrective action before a dangerous condition develops. For example, they may need to unplug a faulty piece of equipment or repair a damaged cable. The LIN is designed to detect both resistive and capacitive leakage currents. Resistive leakage currents are caused by insulation breakdown or contamination. Capacitive leakage currents are caused by the capacitance between conductors and ground. The LIN is typically set to alarm when the total leakage current exceeds 5 mA. This threshold is based on the amount of current that is considered safe for patients and staff. In addition to the LIN, isolated power systems also require special grounding receptacles. These receptacles have an isolated ground conductor that is connected to the isolated grounding electrode. The isolated ground conductor is typically green with an orange stripe to distinguish it from the normal equipment grounding conductor. It is important to use the correct type of receptacle in an isolated power system to ensure that the grounding system is properly isolated. The installation and maintenance of isolated power systems should be performed by qualified electrical contractors who have experience with these specialized systems. Incorrect installation or maintenance can compromise the safety of the system and increase the risk of electrical hazards. Regular testing of the isolated power system is also essential to ensure that it is functioning properly. This testing should include insulation resistance tests, ground impedance tests, and LIN testing. The results of these tests should be documented and reviewed by qualified personnel. In summary, isolated power systems are a critical safety feature in healthcare facilities. They are designed to minimize the risk of electrical shock to patients and staff. The use of isolated power systems requires careful planning, installation, and maintenance. It is important to consult with qualified professionals to ensure that the system is properly designed and installed. Furthermore, the NEC, the National Electrical Code, provides additional guidance on the installation and maintenance of electrical systems in healthcare facilities. Article 517 of the NEC specifically addresses healthcare facilities. This article covers topics such as essential electrical systems, critical care areas, and wet locations. It is important to be familiar with the requirements of Article 517 when working on electrical systems in healthcare facilities. One important requirement of Article 517 is the use of redundant grounding systems in critical care areas. This means that there must be at least 2 separate grounding paths for each piece of equipment. This redundancy ensures that there will be a grounding path even if one path fails. Another important requirement is the use of ground fault protection on circuits that serve patient care areas. Ground fault protection is designed to detect small leakage currents to ground and treat the circuit breaker before a dangerous shock can occur. The NEC also specifies the types of wiring methods that are permitted in healthcare facilities. In general, wiring methods must be installed in metal conduit or cable with a metal sheath. This provides mechanical protection for the wiring and helps to contain any potential fires. The NEC also requires that all electrical equipment in healthcare facilities be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories. This ensures that the equipment has been tested and meets certain safety standards. In addition to the NEC, there may be local codes and regulations that apply to electrical systems in healthcare facilities. It is important to be familiar with these local requirements as well. The enforcement of electrical codes and regulations is typically the responsibility of the local electrical inspector. The electrical inspector will review the plans for new electrical installations and conduct inspections to ensure that the work is being done in accordance with the code. It is important to cooperate with the electrical inspector and address any concerns that they may have. In conclusion, electrical safety is a critical concern in healthcare facilities. The use of isolated power systems, redundant grounding systems, and ground fault protection are just a few of the measures that are taken to protect patients and staff from electrical hazards. It is important to be familiar with the requirements of NFPA 99, the NEC, and local codes and regulations when working on electrical systems in healthcare facilities. By following these guidelines, you can help to ensure a safe electrical environment for everyone. In addition to the technical aspects of electrical safety in healthcare facilities, it is also important to consider the human factors. Healthcare workers should be properly trained on the safe use of electrical equipment and the potential hazards of electricity. They should also be encouraged to report any electrical problems or concerns to their supervisors. Regular safety meetings and training sessions can help to reinforce the importance of electrical safety and keep healthcare workers informed of the latest best practices. It is also important to have a written electrical safety program in place. This program should outline the procedures for identifying and addressing electrical hazards, as well as the responsibilities of each employee. The electrical safety program should be reviewed and updated regularly to ensure that it remains effective. Electrical safety is not just the responsibility of electrical contractors and engineers. It is the responsibility of everyone who works in a healthcare facility. By working together, we can create a safe electrical environment for patients, staff, and visitors. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified electrical engineers and healthcare facility professionals before making any decisions about electrical systems and healthcare facilities. The ongoing maintenance of these systems is extremely important as well. Regular inspection should include checking for frayed cords, damaged outlets, and properly functioning ground fault circuit interrupters, GFCIs. Any identified issues need to be addressed promptly to prevent potential hazards. Furthermore, healthcare facilities should maintain detailed records of all electrical work performed, including inspections, repairs, and modifications. These records can be invaluable for troubleshooting problems and ensuring compliance with applicable codes and regulations. Staying up to date with the latest advancements in electrical safety technology is also crucial. New devices and techniques are constantly being developed to improve the safety of electrical systems in healthcare facilities. By embracing these innovations, healthcare facilities can provide the highest level of protection for their patients and staff. In addition to the points already discussed, consider the importance of surge protection in healthcare facilities. Sensitive medical equipment is vulnerable to damage from power surges, which can disrupt operations and compromise patient care. Implementing surge protection devices (SPDs) at various points in the electrical system can help to mitigate this risk. These devices divert excess voltage away from sensitive equipment, protecting it from damage. Surge protection should be considered for all critical equipment, including patient monitoring systems, diagnostic imaging equipment, and life support devices. Another important aspect of electrical safety in healthcare facilities is the proper management of portable electrical equipment. Portable equipment, such as infusion pumps and ventilators, should be regularly inspected and tested to ensure that they are in good working order. Equipment should be properly grounded, and cords should be free of damage. Healthcare workers should also be trained on the proper use of portable electrical equipment and the potential hazards associated with it. In addition to these measures, healthcare facilities should also have a plan in place for dealing with power outages. Power outages can disrupt patient care and create potentially dangerous situations. The plan should include procedures for maintaining essential services such as lighting, ventilation, and life support systems. The plan should also address communication with patients and staff, as well as coordination with local emergency services. Regular drills and exercises can help to ensure that the plan is effective. Finally, remember that electrical safety is an ongoing process, not a one-time event. It requires a commitment from all members of the healthcare team, from the administrators to the frontline staff. By working together, we can create a culture of safety that protects patients, staff, and visitors from the hazards of electricity. Remember that any alterations or additions to the electrical system should only be performed by licensed and qualified electricians who are familiar with the specific requirements of healthcare facilities. Improper modifications can compromise the safety of the system and create potentially dangerous situations. Moreover, healthcare facilities should establish a process for reporting and investigating electrical incidents. This process should encourage employees to report any electrical shocks, sparks, or other unusual occurrences. Each incident should be thoroughly investigated to determine the cause and to prevent similar incidents from happening in the future. Findings of the investigation should be shared with all relevant personnel. In addition to the technical aspects of electrical safety, it is important to consider the psychological aspects as well. Patients may be anxious or fearful about being exposed to electrical equipment, especially in critical care areas. Healthcare workers should be sensitive to these concerns and take steps to reassure patients. For example, they can explain the safety features of the equipment and answer any questions that patients may have. Creating a calm and reassuring environment can help to reduce patient anxiety and improve the overall quality of care. In summary, electrical safety in healthcare facilities is a multifaceted issue that requires a comprehensive approach. It involves not only technical expertise but also a commitment to safety from all members of the healthcare team. By following the guidelines outlined in this discussion, healthcare facilities can create a safe electrical environment for patients, staff, and visitors.